We build this very powerful technology, AI, and we keep raising ahead and making it more and more powerful, and asking ourselves the question, where could it lead, or what are the risks with it? What are the risks with giving it autonomy and giving it more capabilities?
In this episode, I'm talking with Roman Engeler, ETH alumnus and co-founder of Atla, about developing guardrails for AI agents, and about his journey from the labs of ETH Zurich to building a startup in London. This is the We Are ETH podcast, and I'm Susan Kish, your host. So, Roman, you're in London. You're doing startups. How do you like living in London?
It's interesting. It's definitely bigger than Zurich. There's much more going on, both in kind of private life, in the leisure time, but also business-wise. It's just great to see how many technical people are here. There's a lot of talent working at startups, working in labs, working in academia. So that's also the reason why we chose to be here, just to be in the vicinity of many, many great people.
In terms of places to live, because if I understand correctly, you've lived in Zurich, you lived in Palo Alto because you were in Stanford, and now you're back in London because you were at Imperial College. You wrote an interesting post about startup events and the startup scene, right? That San Francisco had more volume, but London had more quality, more focus. How do you rate those three places? Because all three of them have active startup scenes, and especially in AI.
Maybe to just mention a few points about each of those, I hope that gives a bit of context. So San Francisco, Silicon Valley, it's what struck me there, it's very dense. The city is quite small. Most people work somehow in technology. So you bump into people working at Google Brain in a coffee shop, or at startups in a coffee shop. So you have a lot of encounter on the streets. But also, as I wrote in the blog post, there's a lot of noise. Like, everyone wants to be there, and everyone then also kind of wants to be recognized in the city. So it leads to people being loud, being very vocal about what they're doing, and it's hard sometimes to distinguish the signal from the noise. London is much more diverse. Like, it's very, very big. There's obviously a lot of people working in technology, but there's also a lot of people working in very different domains, which is something I really like about the city, that it's just so diverse, and you can also have conversations that are not only about technology, but bring together kind of different aspects. And then obviously, given that I studied at ETH, also like a very strong city in the startup scene. I actually started my career in a startup in Zurich. And I think what we have seen in the last 2 or 3 years, it's ETH and the ecosystem in Zurich is very strong in things like computer vision and robotics. And there's many, many great startups being developed. The one thing why we then chose London over Zurich, maybe to also add a bit context there, is that London was just bigger. So we felt for hiring people, and if we want to build a huge company, that might be a bit easier in London, given that you have just bigger talent pool that you can leverage. But I think all of them have their advantages and disadvantages, obviously.
Very cool. So you started as a researcher and doing things including, if I recall correctly, something in distributed energy a long time ago. And was it a conscious decision to say, research is great, but I want to go and be a founder? How did you make that transition? Was it a light bulb moment, or was sort of hanging out with other founders, or you read about all the gazillions people were making? What was the spark that helped make that pivot?
I mean, to be fully transparent, it was pure coincidence. So I always wanted to go into a PhD program. Yeah, always wanted to do research, work on machine learning in academia. But then attended a startup speed dating, I think organized by the Entrepreneur Club at ETH, more to see what else is out there, and to hopefully meet some interesting people. And there was one specific startup and specifically a CTO that grabbed my attention and pitched this role as a technical product manager that combines both technology, data science, with also the business and strategy side. And I thought, why not trying it out for a few months? I can always go back to a PhD program or working on a more kind of technical role. But then, never happened. Was very excited by just kind of being thrown in as a very young graduate from university into a startup, but which at the time grew immensely fast, and being able to take on a lot of responsibilities, ownership, shape full kind of product lines. And so kind of the bug bit me, and since then stayed mostly in startups. Yeah.
Got it. So let's talk about Atla, right? First off, can you explain what an agent is? I think probably most of our listeners understand. And then secondly, can you explain what a trace is? That was a little bit harder for me to find a good definition of.
Yeah, there's various different definitions what an agent is. For me, it's in essence, it's a language model, a large language model such as GPT-4 or 5, that has some autonomy about what it's doing. So it has a certain task, and then it has some autonomy of how to accomplish that task. And maybe a good example is a customer support agent. So let's assume you go on the EasyJet website and you want to find out something about your flight, or you maybe want to change the flight to a different one. And now this customer support agent can kind of take your request of changing the flight or knowing some information about it, and then figures out which tools it can use. Maybe it has a tool to check the status of a flight, or maybe it has a different tool where it can rebook a flight to a different day, or to a different kind of from economy to business class. And so has has a range of tools, a range of things that it can use to accomplish a certain outcome. That's for me one way to define an agent. And then a trace is basically the different steps an agent does. So in this example, the agent then might ask you for more information about which flight. Maybe you have booked 2 or 3 flights, and it asks you like for which flight you want to have information. And then it maybe needs to verify if you want to rebook it. Maybe you get or need to pay more. Then it asks you which credit card it should be using, and then it does the rebooking, and then in the end confirms. And so the trace is basically this sequence of steps from asking you which flight is maybe the first step, then checking information on this flight, finding out.
So it's sort of the crumbs along the journey.
Exactly.
Got it. All right. So with that context, would you tell us about Atla? It sounds neat, and it sounds like it's actually has the potential to really have impact. So what is Atla?
So one thing we noticed is that it's hard to supervise those agents. Like they tend to get more complex. We give them more autonomy. They are allowed to plan for longer, to take more steps. And more people are using then such a customer support agent, for example. And it gets very difficult to really understand what is going on. What mistakes does my agent do? Does it, for example, make mistakes when rebooking a flight, or does it give vouchers in cases where it shouldn't give vouchers?
Sort of quality control stuff?
Exactly. And so what we offer, or our value proposition, is that we give you a scalable way of understanding your agent. So we kind of sit there with your agent, and we walk along with it each step. And then we analyze of where did it do a mistake, why did it do a mistake, and we look at many, many different interactions this agent has with users. Maybe on a specific day, there's 1,000 users wanted to get cash back or rebook a flight. And then we start to find patterns and understand, hey, your agent has issues with using a specific tool, or your agent forgets to ask the user for confirmation before it takes an action that is irreversible. And then we highlight that to the user. So we give humans basically a scalable way of understanding their systems, and then with that a headway in fixing it or making it more reliable for their use case.
So you sort of debug the agents?
Yes, either way, yes. Yeah, we debug it, and we also move more and more towards helping people then fix it. Because if you have a very good understanding of what's going wrong, it's not anymore that that big of a leap to understand, okay, what do you need to change to make your agent better? Exactly.
So talk us through some case studies, because it sounded like you had some interesting ones in legal and IP and areas like that.
Yeah. So one of our customers, they build a productivity tool. So they have a variable that records your interactions throughout the day. And then you can ask kind of questions on and recollect your memory. And so they had some issues with actually the context they would give their agent in one of the steps to then produce an output or to give the correct answer. And so we helped them figuring out in all those kind of long back and forths and messages that the agent would take in, but also then produce, to figure out, hey, there was a bit missing. The agent gave some wrong information to the user because there was something missing that didn't get passed on from the search tool. As for example, one specific example. Another one we had is a deep research agent, so an agent that, as a user, you ask a question and then it goes off, it reasons through it, it does some web searches, and it tries to find the right answer to it. And that had some issues with using the search tool, so it would sometimes pass in some wrong arguments or kind of mess up the fields in the function call to the search tool, which then led to either the search tool failing completely or giving back some results that are just not accurate given what the agent was looking for in that specific step.
So it sounds like if it's correctly applied, Atla is better, cheaper, faster as a way to fix the problems. How do you price that? How do you price your service? And have you found clients willing to invest?
So we are having a tiered pricing, meaning that first you can try it for free for 2,000 traces. So you have this option to just give it a go and see if it provides value for you and what kind of insights it can generate. And then we have a tier that up to 10,000 traces per month, we price it at $199 per month. And this is usually more than enough to get the insights you need to understand what's going on in your system and then to fix it. And then everything above is enterprise pricing, meaning we then discuss and see, find a price point that works both for us and the customer. There are a few happy, or there are a lot of happy customers that are using it, that really see this value in not needing to spend so much time themselves in traces. And the users almost like a ticketing system of, hey, let me kind of check what are the things that failed last week. And then we give them a prioritized list and say, hey, there's this specific thing that we've seen occur, 55 times. And then there's this thing that we've seen 37 times. And then you can make an educated decision on what's the thing you now want to focus on this week when improving your system.
So you can sort of almost replicate what I think it was called Jira used to do as a way to do that. Do you integrate into Jira, or are you going to become the next Jira?
Not yet. But we are looking into integrations and making it more part of the workflow. Actually, one idea I'm very excited about is, so far most of the tools they always focus on the human as kind of the user, the consumer. But what we now see with Cursor or Claude Code or Codex is that more and more actually coding agents are doing the work of a software engineer. So they use coding agents to basically do their work and they supervise it. Yeah. And so one way of how I could see it evolve is that we kind of see the coding agent as the user. So the coding agent kind of picks up whatever is the issue, and we give it enough context such that it can go off and fix it. And then it pings you, maybe, via Slack notification or email, and tells you, hey, Susan, I've solved this thing. Here is a pull request that you can take a look at. And if you're happy with it, with the work I did, you can just kind of merge it and integrate it into the application and move on with your day.
Very cool. So let's pivot back to the ETH, right? Because you've talked about how ETH has been formative in that journey to get to where you are and to asking the questions and building the company that you're building. So what was it about ETH that was so distinctive? Because you were Stanford, Imperial College, and ETH. What made ETH different?
I think one thing was the depth. So I took classes in all those universities that you mentioned, and I felt that ETH was the most rigorous in their classes, and especially when it was about the mathematics behind a certain method or a certain proof, we would always be much, much more rigorous than what I've seen at those other universities, which I think helps you just much better understand the foundations, being much deeper, being able to build better intuitions based on that, rather than if you just scratch the surface.
Right?
Yeah. Another thing I really liked at ETH was there was a lot of freedom, especially in the kind of a bit later in the bachelor's and then in the master degree. I had a lot of freedom to take the courses I wanted to take, to work on the projects I wanted to work on, both from the design of kind of the studies itself, but then also from the professors that would supervise. They always were very supportive in going abroad, having this additional experience, being at another place, courses that might not fall exactly within the degree that I was pursuing, just to get a broader perspective on everything.
So you were also known for having signed something which I didn't know existed called the Founders Pledge from the ETH Foundation. Can you talk to us about what that is and why you decided to sign?
Yeah, so I always was very much interested in having an impact and giving back. Already during my days at ETH, I would be a tutor for various classes. And for me, it was always important to, whenever I had something, be it knowledge or other resources, to give it back and to share it and to help others. And so for me, that's also where I see the Founders Pledge is, I think academia and basic research is very, very important. And if there's a way that once I am successful, and obviously ETH played a big part in getting there, in kind of equipping me with the right tools to get there, that I then want to give back and support the next generation of students, but also research that can be done in, and maybe also in areas where there's less funding available from like either industry or the state.
How is the Founders Pledge structured?
It's very loosely structured at the moment. So, which I think is good.
Makes sense.
I think with those things, you don't want to be too prescriptive on what it is, because it just, I think, scares off people. So it's very loosely. It's just this pledge that whenever I'm successful, whenever I, for example, make an exit in my company, an IPO, or sell it to somebody else, that I give a percentage of my earnings to ETH, and then also to discuss on how that's going to be deployed again, if it's maybe for the excellent scholarship, which I received and which I was very thankful of having the freedom that came with it, or if it's more for research in certain areas where there's maybe lack of funding or some other needs.
So let's go back to the topic around AI, right? I cannot go a day without reading headlines about AI and data centers and all the demand and where it's going. But lately I've been reading, especially when the Chinese AI company came out with a much lower rate of consumption or speed, I guess, of their LLMs. That started a sort of a thread that basically says this AI thing, this is like the .com boom times 10, right? It is inevitable. And it was I suppose, inevitable dose of skepticism about it. But what's your sense about the potential for AI and where it's going to go?
It's very hard to predict. I mean, no one really knows. I think the thing that we are seeing is just for the last, I mean, since even before ChatGPT, but really since ChatGPT, we see those scaling laws apply, meaning that you see it seems to be possible to just throw in more compute and more data, and it gets smarter. And that's now for the past 3 years, everyone does it, and it just magically works. The model gets smarter and smarter. And although, sometimes when I use ChatGPT, you when you, for example, write an email, you don't anymore realize the differences maybe between GPT-4 and GPT-5. But I think it has also to do because it's not that of a difficult task to write an email. But where you see a lot of progress is now on more academic, challenging benchmarks. So there's still a lot of progress. The other thing that I think only really started coming up this year is reasoning and agents. So before we had most of these kind of single interactions with the models, or using it as a kind of simple chatbot where you can interact over multiple steps, but it cannot do much more. And now we see all of a sudden those models become very good in using tools in planning. And there's a lot of companies that emerge that do coding agents that go off for minutes, or maybe sometimes even hours, kind of coding up full projects, or customer support agents that all of a sudden automate 80% of support tickets. There's a lot of kind of new applications that emerged, and that's where makes a lot of progress. And it's really an open question of how that pans out in the next 1 or 2 years, if we continue seeing that fast progress and we really get to a level where it gets as smart as humans across most domains, or if there is a wall that we didn't anticipate today that it hits, that just by maybe the architecture of the models or some other constraints, it hits a wall. But for now, this is not obvious that there is something such as a wall that would prohibit equally fast progress in the future as we had over the last 2 or 3 years.
So you sound, bottom line, pretty optimistic.
Yeah, I think if I need to put it in words, I would say I think there's a significant, or there's a good chance that we reach human level intelligence in the next 2 years. But if not, then it probably takes, 10 years or longer. Yeah. So I think either the current paradigm with language models, transformer architecture, keeps working, and we can just throw more compute and data in, and then I think we get there not too far in the future. Or there is such a thing as a wall, and we need to come up with a completely new approach of how we go about it. And then I think it takes much, much longer until we get there.
That makes a lot of sense. Let's say that you meet a first-year student at the ETH. They just came out of Gimme. Their grades were fantastic, right? Or their scores. And they're very excited about having a career in AI. What would you counsel them to study, and what would you counsel them to do with their out-of-school time?
I think I would study computer science, or quite a technical degree. I like computer science because it's more applied. I think you still have a lot. Also, by the way, I did mechanical engineering in my undergrad and robotics in my master, so I didn't do a pure computer science degree, but I would probably go for majoring in computer science and then take a few courses around it in math and physics, just to really kind of get an understanding both of the physical world, and also because I did robotics. Robotics is something that excites me, and so physics
robotics
I think is a great,
wicked cool. Wicked.
Yeah. And math for the strong foundation, and again for the to be able to develop these intuitions and first principle thinking. And then in leisure, or over the breaks and the weekends, work on cool projects with others. Unfortunately, when I studied, the student project house I think it got started when I was in my master's, but wasn't really around. And now there's this great opportunity where there is a place where you can go and you can work on projects from hardware and robotics to coding. And I would do a lot of kind of real world projects with a couple of friends, maybe getting inspired by some courses on projects you can do along with them, and get my hands dirty, try out things, see what works, see what doesn't.
That sounds like a great path. That Project House is sort of the home of the side hustle. It's great.
Yeah, there's also now a lot of or more and more Y Combinator companies in recent batches that came out of that, where people just in the evenings, weekend worked on projects, and then that developed into something bigger. I think browser use is one example of it that came from there. I think also MCP uses a couple of ETH grads that just tinkered around and got excited by what they were doing, and then realized that there's potential behind it, and keep pushing.
So Roman, there are many ETH graduates all around the world, many of whom have followed your path in terms of starting up a company and hope to be or have been wildly successful. How would you recommend they think about giving back to the institution? What are the paths that they could follow?
Yeah, good question. I really do like the work the ETH Foundation is doing. And I mean, for example, in my case, I was very blessed to get excellent scholarships, and there's also other scholarships that allowed me during my master's to really focus on my academic works, on internships or side projects I wanted to do without needing to worry about how do I pay for the tuition fees and the life around it. So I think that's a great way, and also a way of how I'm currently giving back of just enabling students via scholarships to follow their passion. As far as I know, also the ETH Foundation has some other programs where you can support specific initiatives or research in certain areas. I think that's another great way of how to give back and how to allow basic research to be done without again needing to worry about funding.
Very, very cool. Roman, thank you. Thank you for your patience and your enthusiasm, and also your commitment to. It sounds like Atla has the potential to really have impact.
Thank you for having me.
Delighted. I'm going to close with asking you a few of the questions that we ask all of our guests. So the first one is, when you were a little boy, what did you want to be when you grew up? And where did you grow up?
I grew up in Thurgau, like between Zurich and the German border, Constance. Countryside, very quiet, a lot of time playing outdoors with my three siblings, which are great memories. The earliest thing I remember, and that's also why I studied mechanical engineering, is I was fascinated by airplanes. I was just fascinated by how we can build something that can fly. And how can we get such a big thing off the ground into the air? And so I wanted to be an engineer, and kind of already in high school pursued physics and maths as my major, and then went on to study mechanical engineering at ETH. Yeah.
What are you? I think you answered this, but what are you curious or learning about these days, in addition to robotics?
I mean, a lot of time is obviously spent with the startup, so there's not so much left. What I really do like is biographies, so learning about what path great individuals took. And so I'm currently reading the code. It's called The Code Breaker. It's by Walter Isaacson, and it's about the first invention of CRISPR, and then also the application in the COVID vaccine of that. And what's very much surprised me is, so I knew academia is competitive. Just by studying at ETH, I realized that it's something competitive to do. But I was even then surprised on how competitive it is researching at the frontier, and how an invention isn't a thing that happens from one day to the next.
Agreed. What else are you reading? What books are you on the bedside table, or on your Kindle, or whatever you're reading with?
So I recently bought Atla as well, which I'm keen to read.
How Californian of you.
I haven't yet dove into it, but That's one. And then I also like to read books around, especially AI safety. Just try to remember what's I think it's called The Alignment Problem, by Stuart Russell.
What is that about?
It's alignment problem. So it's about basically we built this very powerful technology, AI, and we keep raising ahead and making it more and more powerful, and asking ourselves the question, where could it lead, or what are the risks with it? What are the risks with giving it autonomy and giving it more capabilities in, it can, for example, be misused by bad actors, by states, by organizations that want to harm society. But also it feels like that if we really get to something that is as smart as humans and we want to allow it to autonomously pick up tasks, execute them, because that seems to be economically valuable, and what are the consequences? Could it be misaligned with what we have intended it to be doing, and could that cause any harms to us? And what different approaches exist to make sure that this isn't the case?
The law of unintended consequences.
Yeah.
And when you go back to Zurich, what is your favorite place to have a coffee?
Usually when I go back to Switzerland, I spend most of the time either at my brother's home or my parents' home. I do like the view from the ETH main building. I think that's a very beautiful view. And so I think if I would need to choose, I would probably get somewhere coffee takeaway and go up there to enjoy the view.
It is cool. I completely agree. Roman, thank you.
Thank you, Susan.
I'm Susan Kish, host of the We Are ETH podcast, telling the story of the alumni and friends of the ETH Zurich, the Swiss Federal Institute of Technology. ETH regularly ranks amongst the top institutions of the world in terms of its cutting-edge research, its science, and its people. Those who were at ETH, who are at ETH, and who will be there. Please subscribe to this podcast on whatever platform you listen. And if you enjoyed today's conversation, please give us a good rating on Spotify or Apple or YouTube. I'd like to close by thanking our producers at LE Media and ETH Alumni, and especially to thank you, our listeners, for joining us.